Hello Sushant, hello everyone. We'll wait for 10 to 15 more minutes and then we'll start the session. Let's wait for others to join. Hello Manisha, hi Vaishnavi. Yeah, put something on the chat. So your mics have been muted as always, but your videos are allowed. If at any point of time you want to speak something, you can raise your hand using the meeting option in the toolbar at the top, and then I'll allow your mic and you can unmute yourself and speak. Meanwhile, we are waiting for others to join. If you guys have any doubts from the previous sessions or from the lectures of week one or the previous assignment questions that we had discussed um, in the week one and week two, if you guys have any doubts or queries regarding that, we can ask. We'll wait for a few more minutes before we start. All right. So can you also just tell me if my screen is visible and I mean slides are
Yes.
changing?
Yes.
Okay, thank you, Dr. Satish. Okay, hello everyone. Welcome to the third weekly discussion and doubt clearing session of the course of the NPTEL course Maintenance and Repair of Concrete Structures NOC23-CE06 taken by Professor Radhakrishna G. Pillai of IIT Madras. I am Ashirvad Satpathy. I am a PMRF research scholar from IIT Delhi, and I'm the officially assigned TA by NPTEL for this course, the maintenance and repair of concrete structures. What I do is I usually take weekly sessions of wherein we discuss the doubts or the queries that you might have from the previous week's lectures, and we also discuss the assignment questions and answers in these sessions. And there is another assigned TA from NPTEL. His name is Umesh. He usually takes his sessions on Fridays from 7 to 9 p.m. And I take these weekly discussion and doubt clearing sessions on Saturdays from 6 to 8 p.m. All right. And apart from this, the previous week's lecture videos have been uploaded on YouTube. I have shared the link in the meeting chat. You can check it and log into it if you want to check the last week's sessions. Apart from that, I have also pasted the link of the folder in which I have shared the last week's slides that we used during the session. So you can also check that. All right. Let's start the today's session. In this session, we'll be discussing the week two assignment, two questions and answers. And there are about 8 questions. And typically, this week's lecture was more or less related to the different types of steel that we use in concrete structures and the type of corrosion resistance of these different types of steel and what are the methods or what are the I mean there are bare steel and there are coated steel and how these steels have different mechanisms of corrosion and how they degrade or deteriorate. And at the end of the session, we'll take some doubts related to week two lectures. Week three, week four lectures have already been uploaded. You guys can check it, and we'll take the doubts in the of those sessions in the upcoming lectures. In today's section, we'll be taking the doubts of week two lectures or of the lectures that you of the previous lectures that you might have. We'll also take those doubts as well. All right. The first question of this practice assignment 2 was TM ring test is a test to check. The first option, there are several options. The options were the distribution of the tempered martensite and ferrite perlite phases in the cross section of the steel, tensile strength of the steel, the resistance against the bending induced surface cracking of the steel, the corrosion resistance of the steel, bond strength of the steel. I'll quickly go to the. Okay, sorry. Yeah, I'll quickly go to the meeting You guys can raise your hands and I'll allow your mic. If you want to speak, you can raise your hands using the meeting option. I'll allow your mic and you can speak. Anybody wants to take wants to answer to this question, the first question?
I can answer, but let the other people try.
Yeah, let's wait for one more minute if others, Manisha or I see someone named S, they're present. If you want to answer, then you can raise your hand. All right, Dr. Satish, you go ahead.
TM ring test is basically for distribution of tempered, martinized, and ferrite perlite phases. This is a
Right,
test for that. So
right.
it has nothing to do with tensile strength. Then
Okay,
third, resistance against bending induced surface cracking. Yes, it
okay,
indicates that. And then corrosion resistance of the steel. It has nothing to do with bone strength. So
okay,
corrosion resistance is also the correct answer.
okay. It has nothing to do with bond strength. So you want to see, I want to say that there are three answers to this question. Thank you, Dr. Satish.
Yeah.
Yeah, so basically, I have taken a picture from the lecture slides of Dr. Pillai. So this is the TM ring test basically refers to the tempered martensite ring test. So what essentially happens in the case of TMT or the thermomechanically treated rebars is that uh, the after the steel is steel is rolled into the shape of rebars. It is quenched using water, and this quenching process essentially takes around several seconds. So, mostly, um, the it as mentioned in the lecture as well, it takes around 1 second for the outer ring of the rebar to come down to a low temperature, and this converts the austenite to martensite. The outer ring becomes martensite, while the inner core is austenite, and this martensite is harder in nature, and while the inner core remains um, cooler, and this sorry the inner core is ductile and softer while the outer core is harder, and this inner core remains hot while the outer core has the temperature of the outer core has reduced due to the quenching process. Now this the temperature from the inside, so temperature from the inside gets dissipated to the outside, and this martensite ring ultimately at the end the core becomes converts from austenite to ferrite and perlite. So I'll just write it here. So the outer ring is martensite. It is called tempered martensite because the temperature from the inner core is getting transferred onto the cooler outer core, and therefore it is tempered naturally. So it is called tempered martensite, and this tempering process essentially happens after the quenching process. So this is the outer ring is formed by the tempered martensite, and the inner core is initially austenite, but gets converted as it cools to a ferrite perlite core. All right. So this this is what takes place in the case of a TMT rebar, and the purpose of this quenching and having two different type of materials in the outer ring and the inner core is that the outer ring, which contains the tempered martensite, is harder in nature, has a higher abrasion resistance, and imparts a strength to the steel, while the inner core is softer in nature and it imparts ductility to the steel. So, in the case of TMT rebars, it achieves both high strength as well as ductility. Now, the TM ring test is done the tempered martensite ring test is done to assess the quality of the tempering and the quenching, or the or the manufacturing process of the TMT rebars. So in this case, what they essentially do is they prepare a cross section of the take a cross section of the rebar, the TMT rebar, and then they I mean they polish it. They polish the surface nice and smooth using several grid size sandpapers, and then they prepare a as mentioned in the lecture as well, they prepare a they embed it into the epoxy, so that so as to prepare a contrasting the contrasting color. So this is, oh sorry, yeah, so this is embedded in a epoxy coating, and this is the rebar. So and then they apply 5% nitrile solution onto the surface to etch it. And this nitrile solution is nitric acid in ethanol or ethyl alcohol. So this 5% nitrile solution is applied onto the surface of this rebar cross section embedded in the epoxy, and this can show us these contrasting differences, color differences between the outer martensite core. So this is the outer martensite core, tempered martensite, and this is the ferrite perlite core. And what essentially is the purpose of this test is to assess the quality of the manufacturing process. That, like over in the right portion, right rebar section, you can see that the ring is not uniform. There is some kind of etching at these locations, and at this location as well. And the tempered martensite the tempered martensite coating is also not uniform around all around the ferrite perlite core. While so this is not a good quality rebar. While the rebar on the left has a completely circular cross section of the ferrite perlite core, and the tempered martensite ring outside the ferrite perlite core is more or less uniform. So this is a good rebar. And this is what essentially is done by the quality assessment. Now, apart from this, before the TM ring test, one another test is done, that is the bending test. So both of these tests have to be done in combination in order to check the rebar's quality. And in the bending test, like is shown in the top part of this picture, the rebar is bent, and as you can see in the left rebar, due to the bending process, there is no surface cracks at the tensile or the uh, the longitudinally stressed location at the topmost fibers. There is no surface cracks appearing due to the bending. While in this second case of the rebars, there are surface cracks appearing due to the bending, and these surface cracks will uh, promote the corrosion process. So this cracking, this severe cracking that is happening due to the rebar in the rebar will also let us know about the quality of the rebar. So, where due to avoid any kind of corrosion, we know that there should be uniformity all around the rebar, and there should not be any inhomogeneity present on the surface of the rebar, so as to make a potential difference large enough to promote the corrosion process. So, if it is uniform throughout, like in this case, then it is a good quality of rebar, and it will protect the structure from corrosion. So the answer to this question was, as rightly pointed out by Dr. Satish, the distribution of the tempered martensite and ferrite perlite core phases in the cross-section steel can be checked by the TM ring test. The resistance against the bending-induced surface cracking of the steel, that can also be checked. And so this has to be done after the bending test is done. Bending test plus TM ring test. And effectively, the corrosion resistance of the, I mean, indirectly, as it is mentioned, the corrosion resistance of the steel is also assessed qualitatively by this test. It has nothing to do with the bond strength of the steel. It has nothing to do with the tensile strength of the steel. All right. Moving on to question number two. Which of the following is or are true regarding cold twisted deformed or CTD rebars? The options are: they are manufactured by cold working at a temperature below the recrystallization temperature of the steel. The twisting process increases the corrosion resistance of the bars. The yield strength of the rebars increases with the amount of cold work. The ductility of the rebars increases with the amount of cold work. Cold working results in strain hardening. Which of these answers, which of these statements are correct? Can somebody answer to this question?
I know the answer, but somebody else should try.
Okay.
Arvind, Manisha,
Arvind has joined.
let them.
Yes, Arvind or Manisha S. If any of you guys want to answer this question, please raise your hands. In fact, I'll allow all your mics because anyway, there is not much noise and you guys are muted. So
So, since nobody else is
yeah,
attempting,
Dr.
I will
Satish,
come
go ahead.
forward. So, first one is they are manufactured by cold working at a temperature below the recrystallization temperature of steel.
Okay.
Then, twisting process does not increase the corrosion resistance, rather it decreases the corrosion resistance.
And can you also tell me why it decreases the corrosion resistance, sir?
This IIT Madras, Professor Pillai has done some studies
Mhm.
because more of energy is involved.
Right,
The moment you add more of energy, then it becomes more prone to corrosion.
right,
Then third answer is the yield strength of the rebars increases with amount of cold working. Yes, it increases.
right,
This is also correct. The ductility of rebars increases. No, as the strength increases, ductility comes down.
right.
And then last one is cold working results in strain hardening. Yes, that's correct.
Okay, right,
Because the process itself is based on strain hardening.
right. Thank you, Dr. Satish. Yes. So, firstly, I'll discuss the first. I mean, the first statement. They are manufactured by cold working at a temperature below the recrystallization temperature of steel. That is true. So the cold, twisted, deformed rebars are, I mean, twisted not at the temperature at which steel is produced, but at a lower temperature, which is generally around 400 to 700 degrees Celsius. So this cold working temperature is 400 400 degrees Celsius to 700 degrees Celsius. And this is well below the recrystallization temperature of the steel. The twisting process increases the corrosion resistance of the rebar. This is a wrong statement because, as we know, that a more energy as compared to that in the case of hot rolled steel bars, hot rolled mild steel bars, the more energy is required for the cold twisting of these rebars, the CTD rebars, and therefore, as we have also discussed in the last week's lecture as well, more the amount of energy imparted to a processed material, more has it the tendency to degrade and come back to its lowest energy state. So since more energy is involved in this material, it is more prone to corrosion, and this is true. In fact, CTT rebars have a higher corrosion tendency, have higher corrosion tendency than hot rolled MS steel bars. So this is the wrong statement. The yield strength of the rebars increases with the amount of cold work. So yes, this is a true statement, and as you can see in this view graph as well, um, so this is the amount. I mean, the strength of the increase in strength. So these are the different types of steel that are mentioned. The Fe250, that is the mild steel, and these are essentially type of deformed bars, or HY, high yield strength deformed bars. And high yield strength deformed bars are generally of two types, that are cold twisted rebars, cold twisted deformed rebars, and TMT rebars, that is the thermomechanically treated rebars. And give me a second, just give me a moment, sorry. Sorry. Yes. So there are two. So as the amount of the strength in the rebar increases, so this view graph shows, like this is HYSD. The deformed steel bars have a higher yield strength. So as you can see, MS has a yield strength of around this. Uh, this is in KSI units. And so the deformed bars have a higher yield strength than that of the mild steel rebars. But as we go on increasing the strength of the rebars, the ductility also reduces. So as you can see in this view graph, the strength is increasing this way, but the ductility, that is the maximum strain, the maximum plastic strain that the rebar can undergo before it fractures, that is decreasing in the case of increasing yield strength. So as strength is increasing, ductility reduces, and this actually happens because whenever we want to increase the strength of rebars, we incorporate more amount of carbon in this rebars. So more is the strength, but the ductility reduces. And this is what essentially happens. This is the difference between the mild steel and the deformed rebars. Mild steel is more ductile, while deformed rebars have higher strength. So this explains why CTD rebars have a higher yield strength but lesser ductility. This is another picture taken from Bartolini et al. And this shows the different types of steel that we use in our concrete structures. The reinforcing steel, which is typically of mild steel or deformed rebars. These are the deformed rebars. And this is the mild steel. And these are the pre-stressing steel, which typically use a steel of yield stress higher than 800 megapascals. And you can also see over here, as we go on increasing the strength, sorry, sorry, this is deformed, this is mild steel. And you can see, as we go on increasing the strength, the ductility reduces. So the ductility reduces. The answer to this question are these three statements highlighted in green are correct. So the yield strength increases, the cold working. Okay, the last statement was cold working results in strain hardening, which is again true. You can see that, I mean, essentially the cold working process, as Dr. Satish has highlighted, it is done in so as to increase the strain hardening phenomena in the steel. So as you can see in the case of mild steel, the strain hardening is lesser, as compared to that in the case of HYSD in this graph. The slope after the yield plateau has crossed, the slope of the curve of the deformation of the steel rebar, that is steeper in the case of HYSD rebars as compared to that in the case of mild steel. And this steeper slope indicates that the strain hardening phenomena takes place much in a much larger manner, in a much more um, highlighted manner than in the case of mild steel rebars. All right. So these are the answer to the question. All right. Coming to the third question. As per the lecture, the chloride threshold of bare steel is higher than that of galvanized steel with no surface damage. True or false? Can somebody answer to this question?
One Mr. Ismail Ali Ahmad has joined. I think he can attempt.
Okay, well, wait. If somebody wants to answer the question, please raise your hands.
Should I reply?
Ismail
Yeah,
has unmuted himself.
is yeah,
Ismail,
Yeah,
yeah,
do you
better,
want to
Sachin.
better,
answer?
better. Yes, yes, better.
Steel is higher than the chemistry.
Ismail, you want to answer?
Yeah, so let me say, as per the lecture, the chloride threshold of bare steel is higher than galvanized with no surface damage.
The question is the chloride threshold of bare steel is higher than that of galvanized steel with no surface damage. Is it a true or a false statement?
The chloride threshold is of bare steel is higher than a galvanized steel.
And if true or
False,
if
sir.
it is false, okay, and why? Can you tell me?
Chloride threshold of bare steel, because the surface will be damaged. Automatically, the surface will be getting damaged.
In the case of what? Surface damage as in?
Uh,
No, I
is the
highlighted the
chloride
surface damage portion because I'm going to
no,
ask another question related to that. But can you tell me why is it a false statement of bare steel is higher than that of galvanized steel? It is a false statement. Why?
I cannot.
Okay. Should I
Yeah,
explain?
yeah, Dr. Satish, go ahead.
Yes, sir.
As you provide protection using galvanizing, it has the effect of improving the chloride threshold. System can take more of chlorides without damage,
Right,
as compared to steel without any protection.
right.
That will, with lesser level of chlorides, it will corrode. So answer is false, as Mr. Ismail pointed out.
Thank you, Dr. Satish. Yes, so the answer to this question is it's a false statement. The chloride threshold of galvanized steel is higher because whenever we are galvanizing the steel, let's say this is a steel reinforcement, and we are galvanizing the steel. So essentially, let's consider one example of this. This is a normal steel, and this is a galvanized steel. In the case of normal steel, it only has a depassivating layer or a film around it, which is made up of the initial corrosion products of the steel reinforcement itself, the oxides and hydroxides of iron, right? So this is the depassivating film of the reinforcement. Now, in the case of galvanized steel, what is done industrially is that the steel is placed in a zinc bed so as to prepare a alloy of the zinc and the iron from the steel as a coating over the steel surface. So the steel is intact inside, but there is a coating of the uh, zinc iron alloy over the steel, and this coating is has a higher thickness than that of the depassivating film of the normal steel. And as we know that zinc is more reactive than that of iron, so even if, and again this zinc also produces a depassivating layer around it, which is when it comes in the concrete matrix in contact with the pore solution of the concrete, it also again produces a depassivating layer around itself. So I'll just label these diagrams. This is the zinc or Zn Fe layer. This is the depassivating film around zinc, and this is the steel. In this case, this is the steel, and this is the depassivating film, right? So first of all, this depassivating film around the zinc has to corrode. Whenever chloride attacks inside the concrete, uh, this depassivating film of the zinc has to corrode. After that, that zinc Fe layer has to corrode, and then only the steel will get affected. So in the case of galvanized steel, the chloride threshold will be quite high. The amount of chlorides that is required before the steel starts to corrode, the amount of chlorides that the structure it can intake before the steel, the reinforcing steel starts to corrode, that will be high. And therefore, that is what is called as the chloride threshold, and that will be high. So, so this is a false statement. All right. Moving on to the fourth question. Choose the correct statement regarding galvanized steel rebars. They have high abrasion resistance compared to fusion bonded epoxy coated rebars. The zinc corrosion products are more voluminous than iron or steel corrosion products. The zinc coating can provide some level of galvanic protection even in the case of some scratches on the coating. And I had also highlighted this in the last slide, even if there is some surface damage. Galvanized steel will corrode at the pH of carbonated concrete, say about 9. Addition of chromates to the coating can prevent the hydrogen evolution and enhance the bond strength. Which of these statements are correct? Can somebody answer to this question?
I think Mr. Ismail Ali can try.
Yes, Dr. Satish. Yes, if Ismail wants to answer, you can raise your hand, or I have also allowed your mic. You can unmute yourself and speak.
Correct answer. So this one galvanized steel with will corrode at the pH of carbonate concrete, say about 9. That is correct answer. Correct statement.
Why would you say that? Can you also explain?
Sir, I have heard that means actual as per the lecturing during that recording I just listened, that is a carbonate concrete pH if it is 9, that that time the corrosion will start, sir. Below the 9, below if it is about 9, it will get corrosion will be getting started.
So I guess you're saying it for normal steel. I'm asking about galvanized steel.
Galvanized steel.
Can you go one by
Correct
one
statement.
from the top? All the statements. Can we discuss that? Can you tell
They
me
have high abrasion.
if
They have
they,
high abrasion resistance.
yeah, if they have high abrasion resistance and why? as compared to that of for fusion bonded epoxy coated rebars?
Zinc corrosion products are more, they have high abrasion resistance compared to the fusion bond epoxy coated bars.
Let's discuss the first statement. Yeah, the first statement, high abrasion
Yes, sir.
resistance. Is it true or false?
They have high abrasion. Sir, to be honest, I cannot recall, sir. That's what I am
Okay,
little bit.
okay. Can
The
you go
zinc
to the second
corrosion,
statement? Can
the
you say
zinc
something?
corrosion products are
I will
more.
reply to the first one.
Yeah, yeah, Dr. Satish, I'll give you a chance at the end. Let him try.
First, okay, okay.
Yeah.
Zinc corrosion products are more voluminous than iron bar steel corrosion products.
Is it a true or a false statement? Zinc corrosion products are more voluminous than iron or steel corrosion products.
True, uh, true, sir. This is true.
Are you giving me a wild guess, or
Uh,
you know, do you
Guess
have
that's
any
what zinc
explanation
corrosion
behind your
products are
answer?
more. That's what let me. Zinc corrosion products are more voluminous than iron bar steel corrosion products.
All right. So, if you know the answer to this question, please answer. Otherwise,
No, sir. No. So
yeah.
I can skip, sir. Skip. You can
Okay.
give.
Okay. All right. Thank you. Thank you, Ismail. Yes, Dr. Satish, you can try. You can answer.
Now coming to the first one,
Yes.
they are high abrasion resistance compared to fusion bonded epoxy. Yes, this is correct because fusion bonded epoxy coated bars have sensitivity towards abrasion. So those are poor resistance.
Okay.
Galvanizing provides much better abrasion resistance
Uh
as
huh.
seen in practice. The second one, the corrosion products are more voluminous. Answer is this is incorrect.
Okay. And
These
why?
volume is negligible. Iron, steel, corrosion, there's tremendous increase in volume. Whereas in case of zinc corrosion products, it may be negligible, may
Mm-hmm.
not be much.
Right. Right.
The third one is zinc coating can provide some level of galvanic protection even in case of some scratches. Yes, even if it is damaged, still it will continue to provide protection.
Right.
Whereas in case of fusion bonded epoxy bars, if you have pinholes, it becomes even more prone to attack. That is a problem with fusion bonded bars. So galvanic protection is better in
Right.
if some damage takes place. Then the next question is galvanized steel will corrode at pH. No, it will not. Normal steel will corrode. Uh, in case of GI steel, we have some protection.
Right.
And then chromates as admixtures can prevent the hydrogen evolution. So that will be helpful. So the last one is also correct.
Right. Okay. Thank you, Dr. Satish. I'll again go
Yeah.
one by one for each statement, and we'll discuss why is it correct and why is it not. The first one was high abrasion resistance compared to fusion bonded epoxy coated rebars, and this is a true statement because zinc that is used for the galvanization of the steel rebars, that is a harder material, and the harder material than the epoxy coating that is provided in case of FBEC rebars. So as the material hardness increases, the abrasion resistance also increases, and we are also seen in the lectures as well. Epoxy coated rebars, they are more prone to cracking. If it is exposed to direct sunlight, it is more prone to it becomes a brittle material, because the epoxy coating after it cools down, it becomes a thermosetting polymer, and that is so there are two types of plastic polymers that you might know. The one is a thermoplastic and another is a thermosetting kind of a plastic. And the thermosetting kind of the polymer is more brittle as compared to the thermo polymer, and therefore epoxy coated rebars have a so these epoxy coating of the rebars scratches off or is more prone to cracking than the zinc in the case of galvanized steel rebars. So galvanized steel rebars have a higher abrasion resistance. The second statement is the zinc corrosion products are more voluminous than iron or steel corrosion products. This is a wrong statement because the zinc corrosion products have a lesser volume and they are powdery in nature. So eventually what happens once the zinc forms its corrosion products, these powdery nature substance corrosion products also kind of diffuse into the voids that are present inside the concrete. So it doesn't create a tensile stress due to the volumetric expansion of the corrosion products inside the concrete. So this is a wrong statement. The third statement was a zinc coating can provide some level of galvanic protection even in the case of some scratches on the coating. And to explain this, I'll take the help of this example. What is galvanic corrosion? So I want to explain this first. So galvanic corrosion is a process whenever two different types of metal are present inside a electrolyte, or in the case of concrete, the pore solution acts as a electrolyte. So whenever two different types of metal are present inside an electrolyte, there is the different types of metals have different potentials. So the electrochemical potential of these different metals is different, and therefore this induces a potential difference. And whenever sufficient moisture and uh, oxygen is present, for in the case of concrete, inside the concrete pores, if sufficient amount of moisture and oxygen is present, so these the metal which is more reactive between the two metals, the metals that is more reactive will become an anode, and there the corrosion will happen. So the metal will oxidize, the metal ions will oxidize, and that will be anodic site, and the corrosion will happen at that site. While the metal that is relatively noble, or which is less reactive than the other metal, will act as a cathodic site for the oxygen reduction, the reduction process to happen. So in these two cases, as shown in this image, so zinc is more reactive than iron. So whenever sufficient moisture and oxygen are available, so in the case of galvanized steel rebars, the zinc becomes a cathodic site, sorry, anodic site. The zinc becomes a anodic site, and the steel, so this iron refers to the steel, and the steel becomes a cathodic site, and therefore the steel is protected while the zinc gets corroded.
It is a sacrificial action.
Yes,
Zinc
it is
sacrifices
sacrificial
itself
action, right?
in order to protect steel, it sacrifices
Right,
itself.
right, right, Dr. Satish. Thank you. So this is kind of a sacrificial action, as Dr. Satish has mentioned. So the zinc gets corroded while the steel is protected, and even if there are surface scratches on the steel, so let's say this is a steel, and this is the steel, and this is the zinc layer. If there is a zinc layer and there's a steel. So even if there are surface scratches on the steel, again, still due to the galvanic protection or this galvanic corrosion process, the zinc will keep on corroding. While even if there is a small amount of zinc present at that location over the steel reinforcement, that zinc will corrode before the steel gets affected. So this is the galvanic protection uh, that is being talked about in this statement. Zinc corrodes and steel is protected. Right. Coming to the right hand side image, which shows two different metals that are, one is copper and the other one is iron. And in this case, iron Fe is more reactive than copper, and therefore the iron becomes the anodic site and the copper becomes the cathodic site. And therefore, the copper is protected while the iron gets corroded. And this has happened in a real life example in the case of the Statue of Liberty. So, in the 1980s, it was investigated that the outside coating of the, I mean, the outside material of the Statue of Liberty, uh, which is provided for the aesthetic reasons, that is made of copper. So this is the copper, and the inside material, that is a wrought iron, which provides a structural, which acts as a structural steel kind of a system. So it provides structural support. So this is iron for structural support, and it is I mean integrated with the outside copper covering with the help of these copper saddles. And at these locations, as you can see, the iron gets corroded and deposited while the copper is intact. And this, once the iron is corroded beyond the acceptable limits, it will affect the structural performance of the statue, right? So this is the problem of galvanic corrosion in the case of real life structures that you might come across. So whenever there are two different metals that are in contact, it should, I mean, special care should be taken so that the material that is of more importance to our structure, that should be protected, while the other material that is provided as a sacrificial material, that gets corroded first. And regarding the third, so this was, yeah. So this was regarding the galvanic protection. The fourth statement mentions that galvanic steel will corrode at a pH of carbonated concrete, say about 9. And this is a wrong statement because, as also seen in the lecture, the passivation of process of the zinc. So pro, I mean, whenever zinc is present, the galvanic steel is rebar is present inside the concrete at a pH between I mean at the pH of around 13, 12 to 13, this the zinc around the steel rebar forms this passivating film, as I have already explained, and this passivating film is made of calcium hydrozincate, or CHZ. This is calcium, so it reacts with the pore solution and it forms a passivating film, calcium hydrozincate. This is the initial corrosion product of the zinc, which acts as a depassivating film around the zinc of the galvanized steel rebar, right? And these corrosion products, till about the pH of 13.3, these can form a compact depassivating film around the rebar. But once this the pH is increased beyond 13.3, that will create coarser, or so beyond below the pH of 13.3, the corrosion products will be finer in nature, and hence it will form a compacted, well compacted layer of around the passivating film around the zinc. But once the pH goes beyond 13.3, the corrosion products become coarser, and there is also the problem of hydrogen evolution, which might result in the bond loss. So this is when the pH goes beyond 13.3. But what happens at lower pH? So as you can see, at even at pH of 9, the corrosion rate in the case of zinc is very low, even in fact at the lowest point. So while normal steel can corrode, start corroding below a pH of, let's say, 9, the zinc layer over the steel will can go beyond, I mean below the pH of 8 or let's say 7. So this is the wrong statement that galvanized steel will corrode at a pH of carbonated concrete. So this is wrong. And the last statement was addition of chromates to the coating can prevent the hydrogen evolution and enhance the bond strength. So this I have already explained. At a pH beyond 13.3, there is hydrogen evolution and there is loss of bond strength. So addition of chromates is a measure to get rid of this loss of bond strength. All right. Moving to question number 4. Choose the correct statement regarding galvanized steel. Oh, so this is, oh, sorry, this is the answer. We have already discussed this question. Sorry. So these are the answers, the 3 answers to this question. Sorry. Moving on to question number 5. Exposure of fusion bonded epoxy coated rebars to sunlight with high UV index, typical in many countries, for just a few weeks can result in microcracking of epoxy coating followed by underfilm corrosion even without the presence of chlorides. True or false? Can somebody answer to this question?
Let Mr. Ismail try.
Anyway, you are going to explain the full details. You can go ahead.
Yeah, anybody who wants to try it
Yeah,
can
if you
raise
want
their
to explain,
hands.
you can explain, sir. Dr. Mr.
Anybody who wants to answer to this question can raise their hands.
Yeah,
Miss Vaishnavi has joined. She can try. Should I attempt?
Uh, wait, Dr. Satish. Yes, since nobody else wants to attempt, you can go ahead.
Uh, this fusion bonded epoxy coated rebars are very sensitive to ultraviolet radiation, and micro cracking generally happens
Hmm.
even if exposure is for a very small period of time. This can result in micro cracking, and there can be under film corrosion
Okay.
because chlorides is one of the factors. Even without chlorides, if micro cracking takes place on the surface, even then corrosion can take place. So this statement is true.
Okay. And can you also tell me what is the kind of corrosion that is referred to by here as underfilm corrosion?
I think crevice.
Yes, right. Thank you, Dr. Satish. So last time also we had discussed. Last time also we had discussed regarding crevice corrosion. So first of all, whenever these epoxy coated fusion bonded epoxy coated rebars are exposed to direct sunlight, the UV radiation from the sunlight causes micro cracking of this epoxy coating, and this epoxy coating becomes brittle. And um, uh, since this micro cracking will expose the steel inside, the steel covered inside the epoxy coating, and that will accelerate the corrosion process. And even if there is not any presence, there is no presence of chlorides, then also we had last time discussed about the crevice kind of corrosion. Due to the non-uniformity over the surface, these anodic and cathodic sites will be produced inside the on the steel surface, and that will promote the crevice kind of a corrosion, which will deepen at that particular location. So this is the underfilm corrosion. Even if there is a epoxy coating, but if it has surface micro cracks, then it will accelerate the corrosion process even without the presence of chlorides. So this is a true statement. And This under film corrosion is the crevice corrosion. All right, moving on to sixth question. Choose the wrong statement or statements regarding the corrosion mechanisms of cement polymer composite CPC coated steel rebars when coating is applied on sand-blasted steel surfaces. The statements are: the coating helps in reduction of oxygen supply, the coating acts as a sacrificial layer for the steel, the coating helps in the formation of a thin passive layer of a passive film on the steel surface, the coating eliminates direct physical contact between metal and electrolyte, the coating should not be applied on the rusted steel surface. Which of these statements is wrong? Can somebody answer? Please raise your hands if you want to answer. Aishwarya, Ismail, Manisha, Vaishnavi, any one of you wants to answer, wants to attempt to this question? I would encourage you guys to keep this session interactive so that we all will learn together. All right, Dr. Satish, go ahead.
We have to choose the wrong statement regarding
Right,
the corrosion mechanism.
right,
And the protective system is cement polymer composite,
right,
which protects the steel rebar. Now, it had been applied on a sandblasted surface.
right,
Obviously, there's good sticking power, and it appears to be a good system. So the coating helps in the reduction of oxygen supply. Yes, it acts as a barrier. Now we have to choose the wrong answer.
right.
So this is correct.
This is
The
correct.
coating acts the coating acts as a sacrificial layer for the steel.
No,
No, this is wrong because it protects. It's
right.
not like a layer of zinc which acts as a sacrificial layer. This is different. It will
Mhm.
protect. It will not sacrifice itself. Now the third one is the coating helps in the formation of a thin passive film on the steel surface. Yes, obviously correct. This is correct. Then coating eliminates direct physical contact. Yes, that is also correct. And
Okay.
the last one is also correct.
Should not be applied on a rusted steel surface. Right.
Yeah,
Okay. Thank you. Thank you, Dr. Satish. Yes, as he
yeah.
has already mentioned, so the cement polymer composite, what essentially means is that it is the cement is mixed with the polymer to produce a composite. That the polymer could be epoxy or some other kind of a polymer, and this cement is mixed with that, and this cement polymer composite is applied as a coating over the steel rebars, and when the coating is applied on a sandblasted steel surface, the sandblasting of the steel rebar is done in order to increase the bond, enhance the bond between the polymer composite and the steel surface, right? So this coating, there are two actions to applying this coating. This coating helps the rebar, protects the rebar by two actions. The first action is, since cement is present, so it increases the alkalinity around the steel rebar, right? So I'll go to the slide. Yeah. So two actions of CPC coated rebars. One is enhanced alkalinity because cement is present, and the other action is it reduces the physical contact of the steel with the other material, with the concrete or with anything else that comes in contact with the steel rebar. So it provides kind of a physical barrier over the steel from the concrete. So since this coating provides a physical barrier, it also restricts the flow, restricts the steel from getting in contact with oxygen or moisture. And so this is a correct statement. So we have to pick wrong statement. The coating acts as a sacrificial layer of for the steel. No, it doesn't act as a sacrificial layer. As we have discussed in the last slides, galvanized steel, in the case of galvanized steel, the galvanized portion or the zinc acts as a sacrificial layer. But since this is the cement polymer composite, it's not a metal, and therefore it won't act as a sacrificial layer of steel. The coating helps in the formation of thin passive film on the steel surface. Yes, that is why it is applied. The coating eliminates direct physical contact between the metal and the electrolyte. That's what I've already discussed. The coating should not be applied on the rusted steel surface. And this is true because if the steel is already rusted, even if you apply coating over it, once the rusting process has already started, it will continue to happen because already there is a cathode and anodic sites present over the steel surface. And even you block the further contact with the electrolyte or the oxygen or moisture, it will still continue. So this the coating should not be applied on a steel rusted steel surface. This is also again a true statement. All right. Moving on to the seventh question. You're required to select the type of reinforcement to be used for the construction of a highway bridge in a remote coastal area where the average relative humidity is around 70 to 80%. The average humidity is around 70 to 80%. The design service of the structure is 110 years. So the design life is quite high. Based on the understanding from the lecture, select the most durable type of rebar from the options given below. Also, sandblasting is not allowed. Sandblasting is not allowed, and the structure needs to be designed for ductility. So these are the things you have to keep in mind. Sandblasting is not allowed. Ductile, the structure has to be ductile, or probably in an earthquake-prone region. The relative humidity is around 70 to 80%, and the life of the structure is quite high, around 110 years. Which of these rebars will you select? Cement polymer coated steel rebars, galvanized steel rebars, hot rolled mild steel rebars, carbon fiber reinforced polymer rebars. Can somebody answer to this question? It's a good question. And you have to also give your reasons why you want to select the type of rebar you want to select over the others.
Let KR, AR, Ismail, Manisha, or Vaishnavi try. If they don't come forward, then I'll reply.
Yes. We have someone named Kunal Rathod who has joined. If you want to answer to this question, please raise your hand. Manisha, Vaishnavi, Ismail, Aishwarya, and you wants to answer? Okay, Dr. Satish, you want to answer?
Okay, cement polymer coated steel rebars will function properly only if you clean the surface properly. So sandblasting is not allowed. In that case, cement polymer coated steel rebars will not work. Then galvanized steel rebars, yes, as came out in the lecture also, they told that its performance has been proven. This is the best type of material for this type of situation. Then third one is hot rolled mild steel rebars. Uh, it will definitely corrode because it is saline environment. And last one is basically for strength. And again, you require good sticking power. So unless you clean the surface properly, it will not stick properly, and there will be delamination. So obviously, galvanized steel rebar will provide the best protection in this type of situation.
Okay, thank you. Thank you, Dr. Satish. Yes, So we'll go on discussing again one by one all the type of rebars and what is the problem and why should we not select these rebars in this particular situation. The cement polymer coated steel rebars are good, but you have been told that sandblasting of the steel is not allowed. And if the sandblasting of steel is not allowed, any kind of coating that you provide over the steel, that will not have a good bonding with the steel. So since sandblasting is not allowed, this is not a good idea to use the CPC steel rebars. So this is rejected. Needs sandblasting because it needs sandblasting for good bond with steel, right? Coming to the third one, the hot rolled mild steel rebars. Now the design service of the life of the structure is termed as 110 years over here. And hot rolled mild steel rebars are ductile, so it is designed for ductile. So it is ductile, but the relative humidity is very high, 70 to 80%, but prone to corrosion. These kind of rebars, hot rolled mild steel rebars, are prone to corrosion since RH is high and design life is 110 years. So this will not work, even if it is the most economical option over here. Most economical option. Again, carbon fiber reinforced polymer rebars. This is not among all the four types of rebar that is mentioned. This is the costliest. And again, it has a problem. So whenever the alkalinity is increases, so these kind of polymer rebars have a experience surface etching, and they are unstable in the alkaline environment. So carbon fiber reinforced polymer rebars, they will not be suitable for this high service life, high design life structure. Also, these polymer rebars also undergo this debonding and debonding of the fibers, as well as there is shear failure within the rebar, as you might have seen also in the lecture. So if this is the rebar, there is kind of a shearing off at these certain locations on the rebar. So these are brittle in nature. These rebars again are brittle in nature. So since we have to design the structure for ductility, we can't use this. Also, these rebars undergoes debonding of these fibers sometimes, and that creates a lot of problem because these rebars won't be functional structurally then. So this is discarded. Hot rolled mild steel bars is discarded, and the last one is galvanized steel rebars. This functions very well in the kind of list the conditions that is listed above. High relative humidity will accelerate probably the corrosion process, but again, since it is galvanized steel, so it is the zinc will get corroded while the steel remains intact. So that will in turn reflect on the service life of the structure. The design life will increase. Sandblasting is not required for galvanized steel rebars, as it undergoes a totally different chemical and industrial process, and the structure needs to be ductile. And yes, this galvanized steel rebars are ductile in nature. So, this serves all the galvanized steel rebars serves all the kinds of conditions that we have listed above, and therefore that is the answer. And coming to the eighth question, which was the last question of this practice assignment, choose the correct statement or statements regarding the corrosion in post-tensioned concrete systems. The post-tensioned duct should not be filled with water before grouting. High bleed grouts can prevent the formation of voids in the duct. The end anchorage zone should be covered with cementitious coatings. The end anchorage zone should be covered with metallic plastic caps for long-term protection against moisture attack. Which of this is correct? Can somebody answer to this question? I guess we have more people who have joined.
Yeah.
Hitesh Kumar has joined and Arvind. If any one of you wants to answer to this question, please raise your hands. Come on, this is the last question. Uh, Please raise your hands to answer this question.
Since nobody else is coming forward, should I reply to this one?
Yes, okay, go ahead.
In case of pre-stressed concrete system, post-tensioning is the case as stated in the question.
Mm-hmm.
The PT duct should not be filled with water before grouting because we are not very sure that all the water will be expelled out. So some water
Right.
may remain and it will create problem of corrosion, and
Mm-hmm.
particularly when high stress levels are involved. So this answer, first one is correct.
Right.
Then high bleed grouts can prevent the formation of voids. No, high bleed
Okay.
grouts are not desirable. Then the end anchorage zone should be covered with cementitious coatings. In contrast to the cementitious coatings, as came out in the lecture, they suggested that anchorage zone should be covered with metallic oblique plastic caps. And among these two also, preferably metallic, was told by Professor Pillai. He
Okay.
says that plastic caps can also degrade because of exposure to ultraviolet radiation, etc.
Right.
Metallic are still better.
Okay.
This is what. So last one is also correct.
And this is wrong. Okay. Thank you, Dr. Satish. Yes, the correct answer to this question are the first and the fourth statements. The post-tension duct should not be filled with water before grouting because if some of the water remains inside the duct, that will promote the corrosion process even if even after you grout it. If that water is present within the duct at any location, that will promote the corrosion process. High bleed grouts can prevent the formation of voids in the duct. This is a wrong statement because when there is higher amount of bleeding in the grouts, that will in fact, promote the formation of voids. So that will be that portion of the grout will be porous, more porous in nature, and that will again promote the corrosion process. The end anchorage zone should be covered with cementitious coatings. Again, it is a similar answer. This statement is wrong because the cementitious coatings will be porous in nature, that they are not totally impervious to moisture and air, and therefore that will again provide a chance of corrosion. And therefore, the end anchorage zone should be covered with metallic or plastic caps. As Dr. Satish has already mentioned, plastic caps, again, they have the chance of becoming brittle with the exposure to sunlight, and they have the chance of cracking due to the exposure to UV rays from the sunlight. And therefore, metallic caps, which again do not corrode, and special care needs to be taken so that they will protect the steel inside, uh, so that the steel doesn't get affected from corrosion. So these two are the right answers. And that ends the assignment questions of week 2. Thank you. And if you have any questions related to the lectures of week 2, I'll be happy to take those queries or questions, and we'll try to discuss and answer. You can raise your hand and ask your queries or questions. Yes, do any of you have any questions related to this assignment, or related to the previous assignments, or related to the lectures of week 1 or week 2? Okay, Vaishnavi Upadhyay has raised a hand. Yes, Vaishnavi, I have allowed your mic. You can unmute yourself and speak.
Yes, sir. Sir, I don't have any doubt. I just wanted to say thank you for the such a wonderful session. We realized our mistakes also, and we definitely saw that where we can improve more for the course content. So thank you so much.
Thank you, thank you. I expect you to answer to some of the questions next time. Thank you so much for your compliments.
Yes, sir, definitely.
Sure, sure. Thank you. Thank you for attending. Does anyone else have any questions? Okay, Dr. Satish has raised his hand. Yes, Dr. Satish.
Well presented.
Thank you,
It
thank you.
was a wonderful session. Very well presented.
Thank you, Dr. Satish. Thanks to you for answering to all the questions, in fact.
Thank you, because I'm still a student of the subject, teaching also. I'm teaching repair and rehabilitation, retrofitting. The
Sure, sure.
subject is a composite subject. I'm teaching that subject.
Thank you, thank you.
So that directly useful to me.
Thank you. Thank you for attending. Yes, Ismail has raised his hand.
So thank you for the this. Can thank you once again. I'm sorry for that harsh reply to Mr. Dr. Satisha.
Oh, no, no,
Thank you.
it's okay.
Okay.
Anyway, yeah, thank you for attending and you thanks for trying to answer the questions.
Thank you. Today is the first day. That's what I don't know. What is the things happening? That's what I tried. I know. I just get the way. What is the thing happening? I will
It,
prepare next time and I will be coming.
it is your first day?
Yes, I just tried. Last time I tried, but I cannot able to join. This time I was trying. I can able to
Okay,
join.
okay,
That's what.
okay. This is
Thank you.
the
Thank you
third
for that.
week that we took this lecture
Yeah,
session.
yeah, understood. Last two, yeah, yeah. Last two times I tried, but I cannot able to get attend. That's what. It's what it was my some from mobile problem. That's what.
Mm-hmm. Okay, yeah. Anyway, yeah, you can attend
Thank
the
you. Thank
upcoming
you.
lectures and you can check the last week's lecture
Next session.
sessions
Yeah,
on
sure,
YouTube.
sure, sure,
Okay.
sure, sir. Thank you. Thank you.
Anybody else? Do you have any questions or queries? So the session for today has ended in terms of these questions, the assignment questions. But the lecture session will go until 8 p.m. So at any point of time, if you recall or if you want to ask something or speak something, please raise your hand. I'll allow your mic and you can speak. For the time being, I guess your queries have been addressed. Dr. Satish and Ismail, you had raised your hand, so I am lowering your hands for now.
Yeah.
Yeah. Okay. Thank you. So you guys are free to leave if you don't have any other questions or queries, and but the session will go until 8 p.m. So you can stay if you want, and you can ask any questions. Otherwise, you can leave. Thank you. All right, we are closing the session for today. Hope to see you guys in the next session on Saturday at 6 p.m. Thank you.